Hello everybody, this lesson is from Unit 7, Lesson 1. So we're into the Relations and Functions unit, and this is the Foundations lesson, which is going to be kind of an opening into the skills that we'll need for this unit. So it's just a review of vocabulary terms that we need. For slope, remember that's the steepness of a line. The y-intercept is where it's crossing your y-axis. We'll also need to know about the absolute value. So a number is positive distance from 0. The word evaluate just means to substitute in and solve for a variable. And the hyperbola, actually, we won't have to cover. I just forgot to take that out. So review of finding the equation of a line. So in units 3 and 4 and even 5, we've talked about how to write the equation of a line. And most commonly, we'll list that in slope-intercept form, which is y equals mx plus b, where m is the slope and b is our y-intercept, or where that line is crossing that y-axis. So if we want to find the equation of line D, here is our line D. I can see that it's crossing my y-axis at 3, so that would make this part of my equation plus 3. And my slope, now you can count on the graph, the rise over the run, or use your slope formula, which is the change in your y, so y2 minus y1 over x2 minus x1, and subtract the values of those two coordinates, or you can just count if they're nice coordinates. So the rise is up 1, 2, 3, so that's a positive 3 for my rise. And then starting from here to the right 1, that would be a positive 1. So that would give me a slope of 3. So m equals 3. So in my equation, I have y equals my slope, so 3x plus 3, because that's where my y-intercept was at 3. So now I want you to calculate out what the equation is for line B. Line B is here, so calculating that out. And actually, I think I'm going to change it to calculate out for line A, because line B is not crossing at a nice intersecting point on here. So we are going to instead calculate out for line A. So looking at line A, using slope-intercept form, so y equals mx plus b, I can see my y-intercept is at a minus 3, so b equals a negative 3, because it's crossing my y-axis at a negative 3, and it has a slope. So counting up 1 to the right 1 has a slope of 1. So my slope is 1. So writing it as an equation, I would have y equals 1x minus 3, or you could think of it as y equals x minus 3 for line A. For line B, if we wanted to write the equation of that line, since it doesn't cross at a nice intersecting point for that y-intercept, that's when you'd want to use slope-intercept form. So slope-intercept form is a different type of an equation. You'd have to list it out as y minus y1 equals m times x minus x1. So calculating out the slope, down 1 to the right 1, 2, 3, 4. So that would be a slope of a negative 1 over 4. So in place of m, I would have a negative 1/4. And then if you remember for point slope form, the x and the y coordinates refer to a point on this graph. So if I use this point here, that's the ordered pair 1, 1. So in point slope form, y minus my y coordinate of 1 equals my slope of a negative 1/4 times x minus my x coordinate of 1. And then this would be the equation of that line. And you could transfer it into slope-intercept form by distributing through the 1/4 in your second set here, and then solving for y. But you can leave it right now as point slope form. The other part of this lesson is with working with absolute value. And if you remember, absolute value is always returning the positive form of a number. And so we have -3 times the absolute value of m minus 10. We want to evaluate this equation for m by substituting in 6 for m. So using order of operations, when you plug it in, 6 minus 10, we want to evaluate first. It's inside our absolute value. So -3 times 6 minus 10 is a -4. But since this is absolute value, this is not a -4. It's actually -3 times the absolute value of a -4, which is 4, giving us an answer of a -12. Another example, this time we've got k equals -4. So we'll substitute in -4 first, so I recommend rewriting the entire problem. So -4 minus 2 times the absolute value of 3 times a -4, and then minus 1. So order of operations, let's do this part first. -4 minus 2. If we add the opposite, that's actually the absolute value of a -6 times the absolute value of 3 times a -4 is a -12, and then minus 1. So the absolute value of a -6 is 6 times the absolute value of a -12 is 12, and then minus 1. 6 times 12 is 72, minus 1. Our answer then would be 71. And in this example, substituting in 9 in for C. So we'd have 3 on the outside, and then 2 times 9 minus 2 all over a -4. So treat this as this whole part doing first. Simplify inside this first. So do the numerator and then divide by that -4. So 3 times the absolute value, 2 times 9 is 18 minus 2 all over a -4. Then I have 3 times the absolute value, 18 minus 2 is 16 over a -4. Over here, 3 times the absolute value, 16 divided by a -4 is a -4. The absolute value of a -4 is 4, so 3 times 4, and in this case, my answer is 12. So the practice assignment for this one comes from an online worksheet. It is, all of the foundations lessons are kind of online links. You can also get them through the online textbook, but not in the actual hardcover textbook. So problem set A, numbers 1 and 3, and problem set B, numbers 1, 5, and 7. Make sure you're checking your answers. If they check out, then you can take that online assessment. But I have live help if you're not sure on some of them, Monday through Thursday from 10 to 11, and Fridays from 9 to 10. You can always reach me on Skype or give me a call or always send me a K-mail. And if you don't have the link to these questions, here are the practice problems. So for question number 1 and 3, determine the equation of line A and line C. And then for problem set B, evaluate each of these using absolute value. So make sure you simplify using correct order of operations and substitute those numbers in.